we're going to compare f of x equals x plus 3 squared and f of x equals x minus 5 squared. And I'm going to look at the graphs of both of those. So in this first section, we're just going to plot some points. So if I plug negative 5 into f of x equals x plus 3 squared, so I'll do all of that in purple, and I'll do all the other one in red. So if I plug negative 5 in for x, out will come 4 for y. If I plug negative 3 in, then I'll get 0. And if I plug negative 1 in, I'll get 4. I'm just picking some negative numbers. I'm going to the right, and then at 0 I get 9. And one thing I need to notice is that my y values repeat. So I know that I'm going to have a complete graph, and I'll tell you what that means as soon as we look at it. So I plot those points, and now looking at it, because it is symmetric, then my y values will repeat. And so I've plotted negative 5, 4, negative 3, 0, and negative 1, 4. And there's I'll go ahead and do the same thing for the other one, and then we'll go back and compare the two. So for the red graph, then, if I plug 3 in, out comes 4. If I plug 5 in, out comes 0. And if I plug 7 in, out comes 4. And so, again, since my y values are repeating, I can go ahead and graph that. You can see that they look alike, but they've just been moved. So this section is kind of looking for patterns to see what the relationship is. And then in a later section, we'll actually find the definite pattern. So looking at the first one, the purple graph, we see that the vertex, which is the lowest point on the graph in this case, is negative 3, 0. And looking back at my equation, you can see that there really is a 3 somewhere in there. So again, we're just looking for patterns at this point. And then it has an axis of symmetry, which is the mirror, that the two pieces of purple graph will match each other around that mirror. Well, the equation of that dotted line is x equals negative 3. So notice the negative 3 in the axis of symmetry and the negative 3 in the vertex both match. And then we talk about the vertex being either a minimum or a maximum. And since this one opens up, it's a minimum. So I'll do the same thing for the red graph. The vertex, we can see that lowest point is 5, 0. And if you look back at the equation, there is a 5 in there. And then the axis of symmetry is x equals 5. I didn't draw the dotted line, but it's that vertical dotted line that has to go through the vertex. And then this is also a minimum. So at this point, again, you're plotting points, you're starting to look for patterns.